Well, good morning. We're going to be working on exercise 3, power and DC circuits, and the power formula actually comes in chapter 4, so you're going to have to wait if you haven't started chapter 4 yet, but I'll give you the formula in this lab, but you'll be studying that in chapter 4, so you'll have a little bit of time to absorb that, but basically wait and do this lab and then look at the chapter 4 for the formula for power. So in the picture we have two 1K resistors, and we have them right here, and you can see them. Hopefully they're small, but there's one right here and there's one right here, and they're hooked together. There's two 1K resistors and they're hooked together just like the picture for measuring a voltage. So the setup for volts, we have the little jumper across from the one side to the other, but we're going to be reading voltage, and I'm going to give you the readings. So it says go with two 1K resistors in series and go voltage from 0 to 10 in 1 volt steps, and I've got the power supply sitting right up here, and we're going to use channel 1, and I'm going to give you the readings down here. I'll start with I'll read the first couple, but then after that you can read them for yourself. So basically I'm going to tell you when we're at a certain setting on the power supply, and then you can get the reading. So anyway, so we're going to start with 0, and hit enter 0 volts, and the reading is in millivolts, and there it is. It's about 1.6. It's very unstable, but it's in millivolts. So that's our reading for 0 volts. Okay, we're going to go to 1 volt, and this is in volts, 0.9934, in that range. Now to 2, 1.98 something volts. We're going to go to 3. We'll go to 4. We'll go to 5. 6. 7. 8. Excuse me. Clear, Ted. 8. 9. 10. Okay, so now we're going to set the DMM, the digital multimeter, for current. So we're going to take the lead out at the top, and we're going to put it in the bottom. But before we do that, we're going to set the take this jumper out, and we're going to force the current to go through the circuit. So we're going to put another jumper in. We're going to connect the leads so that we force the current to go through the meter, and that's like the picture on the right. Okay, so we're going to get the picture on the right. All right, so now we're going to set it to DC current. I'm going to plug in. Okay, now we're going to come back here, and we're going to go at 0 volts. At 0 volts we should have 0 current, right? And we do. It's in microamps, 1 something microamps. 1 volt. And that's about 0.47 milliamps, 0.470 milliamps. 2 volts, 0.94, 3 volts, 1.47 milliamps, 4, 5, 6, 7, 8, 9, 10 volts. So these are our currents at those various voltages. So now we are going to restructure our picture, and we're going to do two 5.1K resistors, and we're going to do those in parallel. So we're going to do these in parallel. So we're going to restructure our picture a little bit, and we're going to put the two resistors in parallel. So we're going to take these out, these resistors, we're going to take them out, put them over to the side, and always measure your resistors before you put them in, so that you always are aware of what you have. I mean, it sounds ridiculous to say that, but you should always make sure that you have the right values. So I'm going to use these two 5.1K resistors in parallel, hooking them into the same row. Make sure you put them in the same row, and then come over to the other side with your jumper. So now I've got my jumper, I've got my two resistors in parallel per the picture, and I want to go back and measure the voltage. So I'm going to measure the voltage from 0 to 10 volts across these, and I'm just going to measure across one of them. Doesn't matter which one, but I'm just going to measure across one of them, and that's the same as the voltage across both of them. So we're going to go back, and we're going to go switch back to DC volts, and we're going to go at 0 volts up here, hit enter. So again, we're going to go at 0 volts and let that stabilize, and we're reading 2 millivolts. That's okay, that's a very small number, and it just keeps going down. So basically it's almost 0, so it's 0.58 millivolts. Okay, so we're going to go to 1 volt, 0.99667 or whatever volts, 2 volts, 3 volts, 4 volts, 5, 6, 7, 8, 9, 10. So that's our two 5.1K in parallel. Okay. So now we come back and we do the current. So we now have the two in series, but we are going to add the jumper, force the current through the jumper, move the meter down to the current setting, say DCI, and we're going to force the current through the meter. In other words, we're going to make it go through the meter. Okay, we're going to 0 volts. 0 volts. We're reading in microamps. 0.9 something microamps. Go to 1 volt. Two volts. 3 volts. These are all in milliamps. 4 volts. 5 volts. 6. 7. 8. These are all in milliamps. 9. 9 volts. Finally 10 volts. These are milliamp readings. Okay. The last thing it says is to turn everything off. Turn this power supply off, or don't have to turn this off, but turn the power supply off. Go back, use the DMM as an ohm meter, which we'll use up here. This is the ohms. And we're going to test now each of these resistors to see if they're actually what they say they are. So we're going to go to ohms. This is like our first lab. And we're going to test each of these resistors. So here's one of the 1K resistors. So these are actual readings of these 1K resistors. .9993534 K ohms. And the other one. So these are the actual values. .99892 K ohms. So those are your two 1K resistors. Now let's go with your 5.1K resistors. 5.1K. Here's the first one. .00994. And the second one. 5.0904 K ohms. So that is all you need in order to set up and do the rest of your lab report for this one. So that ends the live section of Lab 3. So this is Lab 4, and I would ask you to have the picture of the lab in front of you because it makes more sense, but I'm going to build the circuit just as it's pictured on the second page there, but we're going to be looking at it from the point of view of I'm going to do the setup just exactly the way that it's asked in the lab document. So it says use the DMM connected as an ohm meter to measure the resistance of each resistor in the circuit. And then note that the power supply must be disconnected when these measurements are made. Record these values. So basically I have these two leads here, and I've got my ohm meter on. I got it set to the DMM set to ohms, and I'm going to make a connection. And always don't touch both sides when you're, in this case I'm not touching either side, but here's the 100 ohm, and that is in K ohms, so it's 0.1001 or 100.19 ohms. And once I do that, I'm going to put it in the circuit. So as I'm adding these in, I'm going to be wiring them, and so I'm going to put a little jumper over and put the 100 ohm resistor in to the circuit, and it's just right there by the point A, so I'm going to put that in, and then I'm going to do the jumper between A and B. So that's going to be my plan here. So I'm going to be I'm putting in the jumper now that's called the B jumper, so I'm going to do that right now. Okay, so here's the first of the 220s. And hopefully you can see that. It's 218.95. That's in ohms. And I'm going to be putting in the resistor between the B and the C terminals. I always have to get them in the right row. With bifocals it's always tricky, but you can actually check these and look at them on your own. But basically now I'm doing the B to C jumper, and so I'm going to jumper over to the other side, and then I'm going to have the other 220. So this would be the second 220, and these are the ohms. You got to do this outside of the circuit. You can't have it hooked into the circuit when you measure these. This is 218.21 or 22 or 23, so that's good. And now I'm going to put the second 220 in, and that's the C to D. Then I put the jumper between that resistor and the next resistor. The reason I'm putting these jumpers in is because they're what I'm going to use when I do the current. This is my 330. So I'm planning ahead so that I can get the current easily. Okay, so this would be the 330. It's a 328.96. Okay, and then after that one, I go to another jumper, and then I go to my 0, or go to my ground, or my 0 volts. So I go to my ground, and I have a completed circuit. So now I've hooked the circuit up. Here it is. And I know it's hard to see, but you can look at the circuit as it is, and it says to measure voltage. So basically I'm going to jump down now. What it says in the next number is, I've done number 2 under procedure. I measured the values and recorded those. Now you should have recorded those. Now we're going to go and we're going to use the DMM connected as an ammeter, which is the picture at the bottom. So now I have to take the meter and flip it over to current, DCI, and I have to set my voltage at 6 volts on channel 1. So channel 1 set it at 6 volts, enter. Turn the power on, Ted. We've got to set up channel 1 at 6 volts. Always want to measure to make sure that it's at 6 volts before we do anything. So I'll take my little meter and make sure that it's set at 6 volts. So I'm cheating here. I'm going over with the other one and seeing if it's set. It actually is setting at 6 volts. It should be, but let's just make sure. Yep, 6 volts. Very good. So we're sitting there at 6 volts, or thereabouts. So now I want to measure the current at point A. So at point A, that is before the, okay, so the current comes down through the circuit, and it comes to this jumper to the first resistor, but it's before the first resistor. So what we're going to do is we're going to take out that jumper, or one end of that jumper. We're going to put the other end of that jumper, where that came out, we're going to have another jumper. So we've got two leads here now, and we're on current. So we're going to put the one lead to the one and the other lead to the other one, and we're going to do this at each of these points. So now we've got the circuit, and we've got 5.8 or 5.9 whatever, going up a little bit, 5.89, okay, Make sure everything's installed correctly. That's about 5.9 milliamps, okay? So that is our first reading. That's at point A. The current at point A is that. Now you got to remember to put that, take your extra jumper out and put the original jumper back in at that same point. Now you go to point B, which is after the first resistor, but before the second resistor, and you got to put your extra jumper in. And now I'm going to measure the current between these 2 points. So this is the B point of the circuit. And about 5.90. Take this, the B point. Now the C point. The C point is after the second resistor. If you ever come down and you get 0, it means you've probably you put your extra jumper in the wrong row. So basically, always watch to make sure that you don't have 0. Okay, so this is kind of strange because these are varying a little bit. Maybe there's a little bit of a loose connection someplace, but it should, it should be the same throughout, through all of these. Okay, disregard the minus sign because I could have hooked it up backwards, or the plus to the minus, and we don't worry about the minus signs. Okay, so that's the C. The D is between the last 2 resistors, so we're going to take out the one side, put them in. It's a little more, but not much. So there's a little bit of something's going on in the circuit, but we don't know exactly what it is, but they're about the same. They should all be the same, basically. They should be the same. And the last one is the E at the end. That was the D. Well, this points out is that things aren't always exact, and we're finding that out a lot in this course, but they should be close. This is the E. Okay. So that is answered all of the points A, B, C, D, and E. Record these values. Now, use the voltmeter, the DMM, as a voltmeter. So we're going to take the jumpers and make sure that they're all put back in place correctly. And we're going to use the meter as a voltmeter, and we're going to measure the voltage across each resistor. So we're going to measure across each resistor with this as a voltmeter. So we're going to hit on DC volts. And now we're going to go and we're going to measure at each point. So we're going to measure across the first resistor, A to B. We're going to measure from A to B, and this is across the 100. 0.65 volts. Okay. We're going to measure across the second resistor, which is across the first 220. 1.41 volts, 1.40 volts. We're going to measure across the third resistor, which is the second 220. What do we know about all these? They should add up to 6, right? This is 1.3. And the bigger the resistor, the bigger the voltage, because this is voltage divider time, and we're going to show that with the bigger the resistor, the more voltage across it in series. This is the 330, 1.94. So our values should add up in number 4 to 6. Okay. Now it says use the DMM connected as a voltmeter to measure the value between B and E. So E is the point at which it comes back to the power supply, but B is after the first resistor. So we're going to go back and we're going to now look at the value from B to E, which is everything but that first 100K or 100 ohm resistor. So that is the B to E. That is number 5. Okay, so you have all the data that you need now to answer the questions in this lab report. So lab report number 4, you now have the live portion of this lab report. Here's again, looking at the circuit. Right there is the circuit. One more time, looking at it to see, make sure it looks like the circuit you have on your in your lab report. So take care and fill in the rest of it and submit your report.